Hi guys, welcome back. This is video number 2 on question 16B part 2 from the 2018 extension 2 paper. Okay, so hopefully you have seen the first video, and also you would have seen we proved dy is equal to ze. In this video we're going to do the second part of this question, which is finding the exact value of the ratio yz over BC. Okay, now recapping what we did in the last video, we literally proved that BH is equal to FC. Then to prove, which is the aim of the question in the first part, which is dy is equal to ZE, we used the fact we have a parallelogram, and a parallelogram, opposite sides of a parallelogram are equal. Therefore, we prove that dy equals BH equals ZE equals FC. So these four sides are all equal to each other, and this is probably a good starting point for me to start. Okay, so it's good for me to say this: BH is equal to dy equal to FC equal to ZE. Now, all these are equal because I want to make reference to these all the time, and I want to make sure that you guys understand all these four sides are equal to each other. I'm going to let these four sides to equal x. You can make them equal anything you like. It does not really matter. Now, since BH, dy, FC, ZE all equal to x and equal to each other, obviously, we can start now having a look at this question. So let's start with BC, everybody. So I've got BC, which is made up of BH plus HF plus FC. All right. Now BH, we already mentioned before, it's equal to x. FC is also equal to x. So therefore we have x plus HF plus x. 2x plus HF. Okay, that's BC. HC on its own is equal to simply HF plus FC, and FC is also x, so we end up with HF plus x. So now this is what we have. If we continue, we look at DE. So DE is made up of dy, which is x, yz, we're not sure what that is yet, and ZE, which is also x. So therefore we're going to get 2x plus yz. So DE equal to 2x plus yz. Then we're going to move forward with this. We're going to look at DG. Now, sorry, DE, apologies, DE. So DE we have, which is 2x plus yz. So now we've got BC, which is 2x plus HF. We've got HC, which is HF plus x. And we have DE, which is 2x plus yz. Okay, so that's, I think, everything that we need. Now, let's remember what we did in the first part, because at some stage we did mention something. I here have in front of you BC and HC. So I have an expression for BC and an expression for HC. If you go back to the first video, you would have seen we worked out BC over HC to equal the square root of 2. BC over HC. Hopefully I can find it somewhere. Here we go. Down the bottom here, we've got BC over HC, which is equal to BA over HI equals root 2. So keep that in mind because we're going to use that. Now, from part 1, we proved that BC over HC equals the square root of 2. Okay, now BC from the stuff we just completed is equal to 2x plus HF. So 2x plus HF is equal to, over HC, which is going to be HF plus x. All that equal to the square root of 2. Now, you know what to do with this. So HF plus 2x equals root 2 HF plus root 2 x. Okay, obviously bring all the HFs to one side, factorize, divide, and then we'll end up with HF equal to root 2x minus 2x all over 1 minus root 2. This also can be simplified further by saying this is the same as 2x minus root 2x all over root 2 minus 1. So I'm just literally dividing everything by minus 1. This is very important. We can also rationalize the denominator. So when you rationalize the denominator, you can get an expression for HF. So remember, you can rationalize, factorize first. After you factorize, you can rationalize, and when you do rationalize, you'll end up with the square root of 2x, as you can see there. Okay, that's HF. So now, HF is equal to the square root of 2x. Remember, HF is part of BC, and BC is made up of BH, which is x, HF, which we just worked out to be the square root of 2x, and FC, which is also x. So, what can we say about BC? BC is now going to be simply the square root of 2x plus 2x. Okay? Now, what do we know? We know the following. We know that BC, BC over DE is equal to the square root of 2. You can go back and see why that's equal to the square root of 2. If that's the case, that's equal to the square root of 2. We know what BC is equal to. We just worked it out. 2x plus root 2x over DE, which is 2x plus yz, which is equal to the square root of 2. So what we're going to do, probably expand this, cross multiply. So we end up with 2x plus root 2x equal to 2 root 2x plus root 2yz. Okay, collect the like terms, move things to the other side. We get root 2yz equal to 2x minus root 2x. Last but not least, yz, just to show you, divide everything by the square root of 2. And then again, we can rationalize if we wish. And then we're going to end up with the square root of 2 and factorize. So you get rid of take the x outside. So we end up with the square root of 2 minus 1 x. So that's what yz is equal to. Yz is going to be the square root of 2 minus 1 x. Okay, so we are now almost towards the end. Yz over BC. Okay, remember that. That's our goal. Yz over BC. Do we have an expression for yz? Yes, we do. It is the square root of 2 minus 1 bracket x. Do you have an expression for BC? Absolutely. We worked that out. It's 2 plus the square root of 2 x. You know what's going to happen with the x's? They'll disappear, and then we'll end up with square root of 2 minus 1 over 2 plus root 2. Okay, I'll do that last part. Rationalize by the conjugate, so 2 minus root 2. So what does that give us? It will give us 3 root 2 minus 4 all over 2. And I think that's what we need to show. This is the answer required for this particular question, part 2. If you have any questions, please let me know in the comments, and I hope you enjoyed this video. Thank you. See you soon.